Welcome to the 4-2 trigonometric functions, aka the unit circle. Here in 4-2, we're going to identify a unit circle, which actually we've already done. Describe its relationship to real numbers. We're going to evaluate trig functions using the unit circle. You mean we have to do more than just memorize it? Yes, you're actually going to be using it today. And then we're also going to use domain and period to evaluate sine and cosine functions. And we're going to use a calculator. Thank goodness. So make sure you have your calculators handy, but not until we get to example 5. The first thing we're going to have to do here is we need to talk about some trig functions. And so we got to think about, okay, taking a number line. And if you talk about the circumference of a circle, you're talking about radians, so you're talking about the distance around. We talked about that in class, where your distance around your circle is in radians, and if you want to measure the actual angles, that's where you use your degrees. So, if we let our radian values equal a real number t, okay, if we let that equal a real number t, these are going to be our radian values. It corresponds to a point in x and a y on our circle. So, if you have 0, if you're on your circle, and you're at the point 0, 2 pi, then that means you're at the point 1, 0. So your x is a 1 and your y is a 0. If you think about pi over 2, that corresponds to the point 0, 1. So you have your x and your y. Now what you can do with each of these coordinates is you can define your 6 trig functions. What? 6 trig functions? I thought there was only 3. Ha ha. Remember, everything always has an inverse. You've been enlightened to the wonderful world of the sine of a value, the cosine, and the tangent. And these are all SOHCAHTOA, things you've seen in geometry and things you've seen maybe in Algebra 1 also. Well, they each have an inverse. And so if we let the sine of t equal y, then we find its inverse. And all you do is just, this is a y over 1. You just find the reciprocal of that, which is a 1 over y. We call this cosecant, but we just abbreviate it to be CSC. Okay, if your, so let's think about your sine of t. That is your y value. Okay, this is your sine right here. So in your ordered pair, whatever your y value is, that is your sine of t. If we look at our cosine of t, that's our x value. This is an x over 1. So if we have the ordered pair x comma y, which you can't have any other ordered pairs, then your x is your cosine, your sine is going to be your y. So if we have an inverse of x over 1, that's a 1 over x, that is called the secant, and it's abbreviated SEC. And then finally, we're going to do to have your tangent of t is a y over x, which really means your y, if your y value is equal to sine, another way to write this would be the sine of t divided by the cosine of t. This is your y value over your x value. So the inverse of a tangent, the inverse of y over x is an x over y, which we call this cotangent, not the cot of t. Okay, just because we're abbreviating it doesn't mean that we are calling it the cot of t or the sec of t or the cos of t. Ugh, really? Seriously, who would really call that a cos of t? I'm not going to say any names, Andrew, but somebody may. Alright, well, let's try to figure out how we can use these bad boys and find some of our trig values. So if we're trying to find our 6 trig functions for each real number, so that means we need to find our sine of t, cosine of t, and our tangent of t. And we need to find those 3, but we also need to find their inverses. So the inverse of sine is a cosecant of t. The inverse of cosine is a secant of t. And the tangent of t, the inverse of that is a cotangent. So what we do is we need to figure out what ordered pair goes along with 2 pi over 3. So for the first couple of problems here, you might want to have your unit circle handy. But the best thing to do is try to figure out, well, at 2 pi over 3, that's in quadrant 2. So the point that correlates with 2 pi over 3 in quadrant 2 is going to end up being, well, the x is negative. It's going to be a negative 1/2, comma, positive radical 3 over 2. And I know that because I have my unit circle memorized. So let's fill in all these values, because now we've done the hard part. We had to figure out where our point is. Easy part's up next. Remember, this is your x, this is your y. Your cosine is your x. So cosine t is just a negative 1/2. Your sine of t is just your y value, which is radical 3 over 2. So if we want to figure out what the inverses of those are, okay, if we have a sine of t is radical 3 over 2, cosecant, 2 over radical 3. Inverse of cosine, if cosine's a negative 1/2, the inverse of that would be a negative 2. Ta-da! Man, that's so easy. Oh wait, now we gotta do the tangent. Tangent, look back at your trusty little table here. Tangent is y over your x, or your sine of t over your cosine of t. So if we look at our sine, that is radical 3 over 2, divided by a negative 1/2. So we know our solution is going to be negative. But what you need to do is you need to multiply top and bottom by this. You do have to simplify this fraction. You're going to multiply top and bottom by a negative 2 over 1. Negative 2 over 1. And so these 2's cancel, those negative 1's cancel. You get a negative, well, those cancel, so you just get negative radical 3. That's your tangent. And this is really a negative radical 3 over 1, so if you want to find the reciprocal of that, to find your cotangent, you get a negative 1 over radical 3. There are your 6 trig functions at the point where t is equal to 2 pi over 3. Super sweet! Alright, well, I guess we might as well try b while we're at it. B, we have to list out our 6 trig functions here. So we're going to have sine of t, cosine of t, and we're going to have a tangent of t, and we need to find all of its inverses. So cosecant of t, secant of t, and the cot of t. Haha, just kidding. It's called the cotangent of t. So let's figure out what point we're at. 4 pi over 3. Miss Crab, 4 pi over 3, what quadrant would that be in? Wow, you had to look at your circle. She had to look at her circle.
Not everyone has a
Not
memorized.
that smart.
What was that?
Nothing. Just kidding. Joke's on me. So we have a negative 1/2, negative radical 3 over 2, because we are in quadrant 3. So once again, we go through and we need to list all of our 6 functions. So here's your x, here's your y, which x is cosine, negative 1/2. Sine is negative radical 3 over 2. So we're going to say, well, we need to find the reciprocals. Negative 2 over radical 3. And I'm not going to make you simplify or rationalize your radicals. You're big boys, big girls now. We don't have to do that. It's a wonderful thing you learn in Algebra 1, Algebra 2, but you don't actually have to use them in pre-calculus. Not yet, anyway. Now for your tangent, you got to take your y over your x. This is basically going to be just like the problem above, except your signs are changed, right? So if you take a negative radical 3 over 2 divided by a negative 1/2, you're going to get negative divided by negative is a positive. So you get a positive radical 3. And then for your cotangent, that's just going to be a 1 over radical 3. Super sweet! I love this stuff. Almost makes me want to do 2 more problems here for example 1. Oh, hey, okay. That's a good idea. Here's one we may know. How about this point for pi over 2? Well, if I remember correctly, that's straight up 90. So that means we're going to be at 0, 1. So let's list out our 6 trig functions. Oh, good, we gotta write it again. Yep, gotta write it again. sine, cosine, tangent, and then you're going to have cosecant, the secant, and cotangent. Now, anytime you have one of the 4 points that are on your axes, these are super nice because you're actually going to have some undefined values, but you're only dealing with zeros and ones. So if we look at our x and our y, cosine is x, so cosine is 0, sine is a 1, and then we need to figure out the reciprocal. So the reciprocal of 1, well, that's just a 1 over 1, so that means you have a 1. Problem comes into the cosine and the secant. Well, a 0 is equal to a 0 over 1. So if you say for your secant 1 over 0, yeah, that's not really possible. So what you're going to say, anytime you divide something by 0, that is undefined. So you're only going to get undefined values for your 6 trig functions if you're at one of your 4 axes. Pi over 2, pi, 0, or 3 pi over 2. Or 2 pi, or any multiples of those. So let's look at your tangent. Well, tangent, that's going to be y over x, so 1 over 0. Oh, hey, wait, no. That's undefined also. Make sure you write undefined. Don't leave it as 1 over 0. Now the cotangent, just because the tangent's undefined doesn't mean the cotangent is, because if you flip the 0 and the 1, then that becomes a 0 over 1, which in this case is just equal to 0. So as a short little reminder, anytime you have one of the 4 major points here, you're going to have 2 undefined values. Now they're not always tangent and secant. They're going to vary a little bit because your points are not always a 0, 1. Sometimes they're 1, 0, negative 1, 0, 0, negative 1. But your answers are all going to be 1s, 0s, undefined, negative 1s. It's a good time. Now, last part here on A, finally, is t equals negative 2 pi over 3. Oh, negative 2 pi over 3. Where is it? There's negative 2 pi over 3. Negative 2 pi over 3. Come on.
4.
Oh, it's 4?
3.
It's in quadrant 3. It's also the same as, it's coterminal with 4 pi over 3, right?
Duh.
So if you're, wow. So if your point, if you're at 4 pi over 3, that means you're in the 3rd quadrant. That is a negative 1/2, comma, negative radical 3 over 2. So you write out all your sines, cosines, tangents. Oh man, I'm getting writer's cramp. All these values are going to be the same as what you got for example 1b. Right? Because aren't we using the same point here? So if we're using the same point, you get the same values, which is possible when you have coterminal points. So for your sine of t, that's just going to be negative radical 3 over 2. Cosine's a negative 1/2. You take your sine divided by your cosine, you're going to get a positive radical 3. Do all the reciprocals over here, you get a negative 2 over radical 3. You get a negative 2 here for the secant. And you get a 1 over radical 3 for your cotangent. And that's all the fun you can have with example 1.